Welcome to the UGC EPG Pathshala lecture series in computer science. In this series of lectures, we have been looking at the subject database management system. For today's session, we will be looking at temporal databases. The learning objectives for this session include: initially we are to introduce on the importance of this particular topic, temporal databases. Further, we will try highlighting the various time specifications in SQL. Then we will try explaining the features of temporal databases. And finally, we will try detailing on the aspects of temporal databases. Let us understand from the motivation of temporal databases, with what as a motive temporal databases have initially been started. By the word temporal, we mean timestamp of a data, which is actually time and date putting together. So, time is an important aspect of all real world phenomena. Events that occur at specific points in time, say for example, any event, a person has joined college, then it means at specific instance, maybe specific time is mentioned on top of what is existing as a record. So, events occur at specific point in time, objects and the relationship among the object exist over time. So, this has initiated the ability to model this temporal dimension of the real world, and is essentially been easy to many computer applications like econometrics, banking, inventory control, accounting, law, medical records, land, geographical information systems and airline reservation systems. If you look at any of these applications, or this can even be extended, if you look at any of these applications, takes for example a banking application where any specific operation having been done, this operation encloses a timestamp, which is nothing but when the transaction has happened, may it be a withdrawal, may it be a deposit, at what time this transaction has happened is also taken in control. Likewise, let us try understanding from a medical record, when a patient is being admitted and at what time, and at different time intervals, what is the status of the patient will also be understood. So, this lies as a base, that is, time lies as a base in taking up a specific events, objects and relationship among objects. We will try understanding on the need for a temporal databases. Why do we need temporal databases? It is difficult to identify applications not needing management of temporal data. Almost all applications require temporal data to be provided as part of their application. So, these applications would benefit from built-in temporal support in the DBMS. So, there is a temporal support as part of the SQL's 92's version, whatever that we have been discussing, starting from 92 version of SQL. Temporal support has been provided, which will give more efficient application development. Not only that, because of this time stamping, potential increase of performance can also be noted. So, as we have started with saying, the need for temporal databases, this temporal databases provides a mechanism to store and manipulate time varying information. So, we can store and we can manipulate time varying informations also. Having studied on the motivation and the need for temporal databases, now that we will try to define what a temporal database is. So, if you look at what a temporal database is, a temporal database is a database with built-in support for handling data involving time being related to a slowly changing dimension concept. So, time is the major component of temporal databases, which is related to a slowly changing dimension concept. For example, a temporal data model and a temporal version of structured query language. Further, most of the temporal aspects usually include one which is called a valid time, the other one which is called a transaction time. There are two different events which will be updated as part of any temporal event occurring. One is called a valid time, the other one would be called a transaction time. We will try to understand on the valid time first. Valid time is nothing but a time period during which a fact is true in the real world, meaning that there can be a record which can be updated on the real world, any event happening. Say for example, a child is born on a specific date, say 17/2/2017, but then the child transaction has been updated only on 18/2/2017. So here the valid time is the birth of the child is on 17/2/2017, but it has been updated, the birth of the same child is been updated into the records only on 18/2/2017. So the valid time of the birth is 17/2, whereas the transaction time of the same birth of the child is 18/2/2017. So that is the meaning of valid time. I repeat, valid time is a time period during which a fact is true in the real world, whereas a transaction time is a time period during which a fact is stored in the database and it was known. So although we understand from the fact that the child is born on 17/2/2017, but then the transaction has actually happened on 18/2/2017, which says the child was born on 17/2/2017. So now there seems to be two different timing that exist as part of the single record. One of the record which says the actual fact in the real world, which is supposed to be called a valid time, and the second one is also a fact, but this is an update to the database. So this becomes a transaction time. And there is one more time associated with this, which is called bitemporal data, which combines both valid and transaction time. Many a times we may not require the valid time, but we might need the transaction time to be done. So most of the records, by the help of transaction time, we go with the processing, but then by bitemporal data we have both the valid and temporal, we have valid and transaction time which is associated. Thereby we can distinguish when a specific operation has been done or when a specific time period of a particular fact has been done. If you look at conventional databases represent the state of an enterprise at a single moment of time. So if you look at any conventional databases, this happens at a single point in time. The current contents of the database may be viewed as a snapshot of the enterprise. So any specific or current contents will be just a snapshot of a data, and no conventional system interprets temporal domains when deriving new relations. As I have already pointed out, the time is a major component starting from SQL's version 92. Here the major time specification that we consider are date, time, timestamp, time with time zone and interval. Let us understand the format of the date. Date is majorly of 4 digits for a year, starting from 1 to 9999, and months will be generally 2 digits of the month, one from 1 to 92, and date will be majorly between 1 to 31. Likewise, for time as an attribute, there will be 2 digits for hour, 2 digits for minute and 2 digits for a second, plus optional fractional digits which can run very fast. So timestamp, this fractional digits are optional parameters if at all we wanted to include. Say for a running race, we might need this fractional digits which is crucial to decide on the victory of a particular person. So we now look at a timestamp which includes both date and time. So this date and time is 6 fractional digits for the second field. Time are specified generally in universal coordinated time, which we call it as UTC, which supports time with time zone, specific to a time zone. If you look at intervals, intervals refers to a period of time. For example, a transaction which has happened for about 2 days and 5 hours, this becomes a period of time without specifying a particular time. I am not mentioning from what time to what time. Instead, I say this has happened for a period of time, say 2 hours. When the period starts, could more accurately be termed as a span. So now, between one time and the other time, which we actually say it as a span, the span has got a value which has been mentioned as an interval. Personal management in the database. Now let us assume we have an employee relation which has name, salary, title, birth date as pointed as date. It is very easy to know the salary of an employee. Select salary from employee, where name of the specific person should be Ram. It is also easy to know the date of birth of an employee, where select birth date from employee, where name is equal to Ram. If there is a specific record, the date attribute would retrieve the actual date only in 2-digit format. That is, if the person has born on 17/2/2017, then the actual description from a temporal database specification would be 17/2/17. So since all the attributes have only 2 digits, the birth date will be mentioned in this format. So we wanted to keep track of the employee history in case for the relation that we have already defined, an employee relation. Now how exactly we need to convert a simple relation that we have specified here into a temporal database relation. So we need to keep the complete history of the person. If you look at this database, employee having attributes like name, salary, title, birth date, from date mentioned as date, and to date mentioned as date format. So these are the values associated for a specific person named Ram. So the salary detail quite fortunately vary for the same person over a time period. So for an interval in time, this salary has been revised. So take for example, in the first row of this table, or for the first relation of this table, Ram has been appointed as assistant and has been drawing 6,000 rupees as salary. There is an attribute which is called birth date, but for how long he has been served as an assistant, between 1/1/2005, that is 1105 to 1605, that is for a period of 6 months he has served as an assistant. Then after the next instance, we call Ram for an increment of salary by 1,000 rupees, that is for a period of say another 4 months, and there has been the same salary, but the designation, the title has been revised from assistant to lecturer. Then that has happened for some duration, and from lecturer to professor there seems to be increase both in the salary and in the title between a time period. So for this data model, new columns are identical to the attribute birth date. So birth date column is said to be the same for almost all the attributes, not only the birth column. As I have already mentioned, this is an history of a particular employee named Ram. Now to understand or to determine the salary of a particular employee, that is to know the employee's current salary, things are more difficult. So the way in which we tend to represent the current salary, current has to be understood by the system. So we write a SQL query which mentions select salary from employee, where name is equal to Ram and from date as current timestamp and current timestamp to be to date. So we may take the overall history or determine the salary history and say that what is the current salary. So the result of this specific SQL query would be for each person the maximum intervals of salary will be considered. So an employee could have arbitrarily many title changes between salary changes. But then if you look at the determination of salary, we can think it from different perspectives. Like we have one alternative where give the user a printout of salary and title information and have the user determine when his salary has changed. So this would have changed over a period in time, maybe between intervals the title, the designation would have been changed. So we can take the salary list and we can determine on the title information, salary and title information, when the salary has actually changed, or we can use a SQL as much as possible for finding the intervals that overlap or are adjacent and that could be merged. So if you look at the overall temporal databases, in this particular case, as he has joined on one date and ended on other date, the subsequent date or the similar same date, his designation would have been changed. So from that instance, it would go for the other instance, and on the same date it would go for other instance. Likewise it continues, but there can be overlap on certain instances. That is what is the second alternative mentioning about. So find those intervals that overlap or are adjacent to that of the actual query should be merged. So looking at close by on the temporal query languages, we have predicates which precedes, overlaps and contains as its clauses on time intervals. Intersect can be applied on two intervals to give a single interval. So the union of two intervals may or may not be a single interval. So we might have to take a snapshot of a temporal relation at time t consisting of the tuples that are valid at a time t with a time interval attributes projected clearly. Further, this temporal query languages also supports major relational algebra operators like temporal selection, temporal projection and temporal join. If you take for example selection, we might have used selection operator just to pick out some record values from the database. Here time attributes are an additional attribute for temporal selection. Likewise, for temporal projection, the tuples in the projection inherit their time intervals from the tuples in the original relation. So any tuples that has been projected from the actual database will be inherited and be shown as the same time intervals in the result. And finally, temporal join, which is nothing but the time interval of a tuple is a result in which the intersection of time intervals of the tuples from which it is been derived. So where from it has been derived, it will be the intersection of both the time intervals from the selection list. So it intersects it in the intersection. If the intersection is empty, tuple is discarded from the join. If the intersection is empty, tuple is discarded completely from the join. Let us look at a SQL code for which how the temporal aspects have been used as part of the SQL code. Now in this, you can better say by looking at the entire SQL code, what is the operation which we are trying to do. Say for example, I am trying to create a table. This table is a temporary table. So create table temp with attributes like salary, from date, to date, as select salary from date to date from employee where name is equal to Ram. And we try repeating this with an update command on the temporary T1, set T1 to to date which is equal to select maximum of T2 dot to date from temp as T1, where T1 dot salary is equal to T2 dot salary, and T1 dot from date should be less than T2 dot from date, and T1 dot to date should be greater than or equal to T2 dot from date, and T1 dot to date should be less than T2 dot to date. This is the condition that we are supposed to check, where there exists select star from temporary as T2, where T1 dot salary is equal to T2 dot salary, and T1 dot from date less than T2 dot from date, and T1 dot to date greater than or equal to T2 dot from date, and T1 dot to date less than T2 dot to date. We may have to repeat this procedure until no tuples are there to be updated. If you look at this table, initially all the values will never try overlapping, but after one pass, that is after it has been repeated, there seems to be some overlap, whereas after two passes it seems to overlap a lot, but the end result being the common. At the similar instance, for the same SQL code, we will try understanding on the delete code. Loop is executed, so any loop that has been represented, so in the previous case we have done a repeat procedure. Loop is executed log n times in the worst case, where n is the number of tuples in a chain of overlapping or adjacent value equivalent to the tuples. In that specific case, then delete extraneous or non-maximal intervals with a procedure of with a SQL command. Delete from temp T1, where exists select star from temp as T2, where T1 dot salary is equal to T2 dot salary, and T1 dot from date should be greater than T2 dot from date, and T1 dot to date should be less than or equal to T2 dot to date, or T1 dot from date should be greater than or equal to T2 dot from date, and T1 dot to date should be less than T2 dot to date. This is the relational calculus that is associated with the same query that we have presented it on SQL. There are alternatives to reorganize the schema, where we can split the information on salary, title and birth date. Say for example, I write a relation employee with the relation attributes name and birth date alone as one of the relation. There can be another relation which can accommodate name, salary, from date as date and to date as a date. So this becomes a part of employee salary relation, and there will be a list of attributes named name, title, from date and to date, which will be part of employee title. The advantage of this over the other relation is that in the first table we will have only name and date associated, so it will have the minimum of tuples. It will be only one tuple in case of RAM table that we have seen. Whereas if you look at the second table, this salary might have changed over a period of time. So for a time interval, this salary attribute would have changed. So from date and to date, a specific person's salary would have changed. So this interval is being specified on employee salary. Likewise, for employee title, the from date and to date interval is again trying to change, and it's dependent on the designation title. So this has been considered as two separate tables on top of the employee table, where the employee relation has only one record. So by giving this sort of a relationship, we may have to determine the information about salary, which we have estimated on the salary in the previous instance also, but that we found it to be little bit difficult. But now we, having divided the relation into three different relations, we find this writing a temporal relation after having reorganized the schema, now it becomes easy to understand. So we can directly write a SQL query which says select salary from date and to date from employee salary, where name is equal to Ram. Looking at some of the features of temporal databases, Temporal databases support managing and accessing temporal data by providing one or more of the following features. So, there are certain set of features that a temporal database need to have or need to possess. A time period data type, which includes the ability to represent time periods with no end, that is say infinity or forever. So, at the time of birth of a particular child, we may not be able to say the end date. So, having known the start date or the actual valid or transaction time, the end time may not be able to perform. So, in that particular case, we may say it as infinity. So, the ability to define the valid and transaction time period, attributes and bitemporal relations. So, with the help of temporal databases, as we have defined, there are a set of valid time, transaction time and bitemporal time, which will be part of any temporal relation having performed, and there will be a system maintained transaction time, and finally temporal primary keys include non-overlapping period constraints. In short, in this particular session we have looked at temporal databases. We have understood on the need for specifying or need for getting into temporal databases. Not only that, we have introduced on temporal databases with respect to time as the major parameter. So, to understand more on the temporal databases, being time as the major indicator, we have three different time periods associated with temporal databases, which are nothing but valid time, transaction time and bitemporal time. Further, we have looked at the time specification that can be used as part of SQL query language, which are like time, interval and date wise representation. Finally, how exactly the different operators like join, selection and projection could be used as part of the temporal query language has also been discussed in this particular session. Thank you.